a second. So the idea of a mass spectroscopy was that when you have a molecule, you don't know what it looks like. You don't know what it contains. You have no idea what it has. Like if you have ethanoic acid, it's just a liquid. It's vinegar. Okay? So you have no idea whether it's got carbon or hydrogen and what arrangement or how are they arranged. So how do you figure this out? The way you figure this out is that you take ethanoic acid molecule and you bombard it with electrons. You ionize it. You break it down into small pieces. So lots of small particles are going to be produced. You bombard it with electrons and it turns into ions. It loses electrons. So it might form an ethanoic acid ion, like one of the electron would be lost from somewhere. And it would, this is known as the molecular ion. Or what could happen is that the molecule could break down because you're bombarding it with electrons. The molecule could break down into small pieces. Like you might get a COH. I mean, this part might break down. The CH3 part might break down. The CH2 part might break down. So you will have all these, or the OH might break down. So you will have all these small pieces that would be breaking off from the molecule. And those are known as your fragments. And all of them would be positive ions. And you convert those particles into a beam of particles. So there's a beam of particles that is fired that contains that is emitted from this chamber over here that contains the molecular ion as well as the small particles that or fragments that it has broken down into. And then you pass it through a magnetic field. Now, when it passes through a magnetic field, charged particles, they get deflected. So all these charged particles, they're going to get deflected in the magnetic field. And deflection is inversely proportional to mass. Like if the particle is really heavy, it's not going to get deflected by a large margin. And if it's very small or very light, तो उसकी जो deflection होगी वो ज़्यादा होगी, ठीक है? So CH2 has a very small mass, so it's going to be deflected by a large amount. And ethanoic acid, the entire ion, has a much bigger mass, so it gets deflected by a much larger amount. So you get all these particles deflecting. And by looking at the deflection, you can figure out or estimate the mass of the particles. So this is how you measure the AR and MRs of atoms and molecules, etc. You take a mass spectroscopy and deflect it. The heavier it is, the less deflection. The lighter it is, there's going to be more deflection. So deflection can be converted or translated into mass. And that's how you find mass of these particles. And you're going to get two things. One is the mass of the particles, and the other thing that you're going to get is the number of particles that you're going to get. Like if there's a lot of COH ions that are produced when you bombard an ethanoic acid molecule. So if there's a lot of COH ions that are produced, then there's going to be a lot of detection of COH ions. There are detectors over here which give readings when these charged particles hit them. So your graph is going to look like this. Your graph is going to be like this. It's there's going to be percentage abundance on the y-axis, which means basically how many particles are being detected. So if you look at the graph, the mass, the particle that you're detecting at mass 60, that's your molecular ion. That's your CH3, COH plus. I mean, this particle is going to be detected at mass 60. And so on. At mass 45, it's going to be COH plus 1. And what other particles did you have? Like if I, after that, it's going to be at 17, it's going to be OH plus 1. That has a mass of 17. And so on. This one would be, 15 would be CH3 plus 1. This would be CH2 plus 1. And then so on. There would be tinier and tinier particles. You could detect a carbon particle as well. So you'll get a particle which has a mass of 12. Safa, is this clear? This first thing. Is one clearer?
Yeah, sir.
Achha, so, and you can do this for any molecule. Now the first thing, yes.
सर जो फ्रेगमेंट्स है वो इलेक्ट्रॉन के स्ट्राइक करने के बाद फ्रेगमेंट्स कन्वर्ट हो जाते हैं ना?
हाँ, क्योंकि ये आयनाइजेशन चेंबर है ना, तो वो beam of electrons are all striking this, right? So they all, I mean, this big molecule is breaking down into small particles. वो टूट रहे हैं ना छोटे-छोटे pieces में, ठीक है? तो
Okay, sir.
तो थोड़े से molecules होंगे वो intact रहेंगे, but they would turn into ions क्योंकि the electrons might get knocked out, ठीक है? या फिर they would turn into small fragments, ठीक है? And remember, the fragments are a part, it's like a puzzle. The fragments are like the small piece of this bigger molecule. ठीक है, the fragments are not something totally different. वो उसी molecule का कोई part है, कोई उसका छोटा सा part है, ठीक है? अच्छा, anyway, तो हमने मेरे ख्याल से ज्यादा कवर नहीं किया था, ठीक है? अच्छा, जो लास्ट हमने किया था, which was that these fragments give you very vital information about what the big molecule is. Like all mass spectroscopy, they give you this data. This is M over E. This basically means mass. तो यहाँ पे data क्या आ रहा है आपके पास? कि there's, for example, let me explain this question first. The question says that there is a molecule which has silicon, chlorine, and oxygen, and you don't know what the structure is, and you don't even know how many atoms it's got. ठीक है? तो X लिखा हुआ है, Y लिखा हुआ है, Z लिखा हुआ है, and they're asking you to figure out the structure. तो जब आपने when you did the mass spectroscopy of this big molecule, you figured out that you were detecting all these fragments, and this is the molecular ion. The big one is the molecular ion, जो जिसकी mass सबसे ज़्यादा होती है ना, that's your molecular ion, which is this one. This is your M. So that's basically your M. And what will happen now is you have a fragment at 133, you have a fragment at 149, you have a fragment at 247, you're detecting something at 263, and you're detecting something at 396 as well. Okay? Dua, can you hear me?
Yes, sir.
So I'll just at the end of the class I'll go over this with you once more. Okay? अभी थोड़ा late हो गया, तो अभी जितना भी समझ आता है, at the end of the class I'll just sort of go over this again. ठीक है? अच्छा, now so you start off with 133. It's like solving a puzzle. 133, you know that it's got silicon, chlorine, oxygen. So 133, what is 133? If you do the math, it's going to be 1 silicon and 3 chlorines, because that 1 silicon is 28, and the 3 chlorines, that's 35, 35, and 35. So that sums up to be 133. Then you have a bigger fragment, that's 149, that's being detected. So that means कि ये जो छोटा fragment है ना, उसमें there must be a 16 added, which is an oxygen. So the 149 fragment is probably going to be this one. Then you have this 247 fragment. That means the difference between 149 and 247 is 98. That means कि वो जो smaller fragment था ना, if you add 1 silicon and 2 chlorines to it, that gives you a molecule, that gives you a fragment that has a mass of 247. Then you have a fragment that is 263. That means there must be another oxygen added. 16 ka fark hai. So this would be a slightly bigger fragment. And then at 263, you have an even bigger fragment, which is the molecular ion. That's the whole molecule. They have a difference of 133. So that means there's 1 silicon and 3 chlorines. So by joining up or combining the small fragments like a puzzle, ठीक है, जैसा वो jigsaw puzzle होता है, you're able to figure out that what this big molecule is. It's coming out to be 396. So you've been able to figure out the structure. So the thing that you have, the sample that you have, that you're not able to actually figure out how many atoms it's got, by doing mass spectroscopy, you're able to figure out what the exact structure is. And we did another question. They gave you this and they told us that that's the mass spectroscopy. So the smallest fragment is usually the atom. So 14 ke upar you have nitrogen. So I mean, because you know that nitrogen has a mass of 14. You're getting a fragment or a piece at 16. That means it's oxygen. You're getting something at 28. That means 28 wala particle jo hoga, that must be 2 nitrogens bonded to each other. You're getting something at 30 as well. So that means this particle would be 1 nitrogen with 1 oxygen. Okay. Remember, the bigger fragments are a combination of the smaller pieces. And the molecular ion is a combination of all of these. So there's a fragment that's the molecular ion, that's 44. That's the biggest particle. So that must be N2O, 14 plus 14 plus 16. So these सारे छोटे fragments, they're all a part of this bigger fragment. Like you can get nitrogen from it, you can get oxygen from it, you can get an N2 particle as well, you can get an NO particle as well from this bigger molecule. So you're able to figure out, okay, this thing over here is N2O. So anyway, so we had moved to the next phase. This is what we had started discussing. And this is that when you do mass spectroscopy, you can detect the number of carbon atoms as well. Now, when you do mass spectroscopy, how do you detect the I say throw us a do I just I'll just explain this once more. Either let's take the etheric acid molecule again. You bombard it with electrons, so lots of electrons bombarding it. That's your ionization chamber, and the molecule turns into an ion. You ionize it. The molecule ends up losing electrons, or it turns into fragments, small pieces breaking off, like CH3, like CO might break off, OH might break off. So all sorts of small pieces breaking off of the molecule. You turn this into a beam and you deflect it. The beam of particles gets deflected in the magnetic field. So there's this magnetic field, which is over here. 1 second. So here's your magnetic field, and all the particles charge. Haji.
What chapter is this?
This is mass spectroscopy. It's a small topic. TK, we do. After this, we'll probably do moles. TK. I'll send you a list of all the topics in what order we're going to do. TK.
Okay.
This one is a kind of a small topic. It's not that big. As a magnetic, you pass it through a magnetic field, all the particles are going to get deflected. So 3 deflections हो रही हैं. अब यहाँ पे क्या हो रहा है कि all these particles are getting deflected, and one thing that I'm interested in is the molecular ion. The small fragments are going to be deflected more because they are light. So all the small fragments, they're going to be deflected more. But I'm interested at the moment, I'm only interested in this big one. This molecular ion, which is intact. This molecular ion, which is going over here. Now, the thing that we wanted to discuss was this M peak, that we are able to figure out the number of carbon atoms by looking at the M peak. M peak is the molecular ion peak. Now, I told you that carbon has 2 isotopes. In the last class, I told you that carbon has 2 isotopes. Carbon has an isotope which has a mass of 12, and it's got an isotope which has a mass of 13 as well. The probability of getting 12 is a lot higher because the abundance is a lot more. 99% approximately of all carbon is carbon 12, and there's only 1% which is carbon 13. So this molecular ion over here is going to have how many masses? I mean, there would be 3 types of these molecules. And let's talk about those 3 types. It's either going to have a mass of 60, or it's going to have a mass of 61, or it's going to have a mass of 62. So this molecular ion is the heaviest particle that you're going to have. And there would be 3 totally different masses. Why would there be 3 different masses? Either both of the carbons are 12. So it's 12 plus 12. Plus there are 2 oxygens. So that's 16 plus 16. Plus there are 4 hydrogens. So that's 4. So that kind of gives you 60, right? Or the second option. One of them is 13. So you would have one of the carbons is 13. So it's 13 plus 12 plus 16 plus 16 plus 4 hydrogens, right? Or both of the carbons might be 13. So it's going to be, the carbon has a mass of 13. The other one also has a mass of 13 plus 2 oxygens, that's 16, and 16 plus there are 4 hydrogens. Now I'm more interested in carbon's isotopes. I'm not that interested in oxygen's isotopes because oxygen also has a lot of isotopes. But if I just Google this, oxygen isotopes are very rare. I mean, they're not like over here. Oxygen has many isotopes. It's from it goes from oxygen 11, like if you can see this, oxygen can have a mass of 11 to 28. So there are lots of isotopes, but the most stable ones are 16, 17, and 18. But if we just, if I just hover on this one, then you'll realize that almost 99.8% of all oxygen is actually oxygen 16. So the reason I'm not talking about these other isotopes, the other ones are very rare, 0.04%. Oxygen 18 is kind of 0.2%, but it's relatively very rare. So I'm not even considering the other isotopes because they're very hard to detect. So they're probably not going to appear. The percentage abundance is very, very low. The same goes for hydrogen isotopes as well. It has isotopes, but they're kind of rare. So if you look at hydrogen isotopes, if we can, I mean, its isotopes are going to be very rare as well. Like hydrogen 1, पता नहीं होता है कि नहीं. I mean, you can check the abundance. It's stable. It's almost hydrogen with a mass of 1. This one is almost 99.972%. So that's almost 100%. Like most of the hydrogen that you'll ever meet is going to be hydrogen 1. Hydrogen 2 is very rare. Hydrogen 3, this is tritium. That's extremely rare. I mean, trace means that it's going to be very hard to actually find it on planet Earth. So coming back to the point, we don't discuss other isotopes because they are very rare. Carbon's isotope is not that rare. It's 1%, means that out of every 100 carbon atoms, there's at least one carbon atom that is 13. So which is why we're focusing on carbon's isotopes, because we are going to detect it. The other ones we're not going to detect, and the probability is very low. I say anyways, so you have this molecular ion coming in, and this molecular ion has 3 totally different masses. This is going to be known, I mean, this one is known as the M peak. This one is known as the M+1 peak. And this one is known as the M+2 peak. The reason you call them M peaks is because they're all molecular ion peaks. +1 obviously means that if this is 60, this is 60 plus 1. And if this is +2, that means it's 60 plus 2. So all 3 are molecular ion peaks. Yeah, the clear? Is there any question? Is this clear? Alicia?
Yes, sir.
Yes.
Okay. So, and remember, I'm ignoring the fragments. There would be lots of fragments. वो छोटे उनकी mass कम है. So they would be deflected by a large margin. So there would be lots of detections over here, but I'm not interested in those at the moment. So I'm getting 3 different peaks. So the question is, what is the probability of those 3 peaks? Like, what's the probability? So I'm going to calculate, I'm going to go into probability now. What's the probability of getting 60? Like, what are the chances of getting 60? So it's if you know basic probability. The first one should be carbon 12, and I mean, it's got 2 carbons, right? The first one should be carbon 12, and the second one should also be carbon 12. When you have and in the statement, that means the probabilities are getting multiplied. So that means, so I'm going to write this down. So it's going to be carbon 12. The first one should be carbon 12, and the second one must also be carbon 12. So if I do some math, it's the probability of getting carbon 12 is approximately 98.9% over 100. And the probability of getting the other one as carbon 12 as well is also the same, 98.9% over 100. Okay, so this is basic probability. So if I do this on my calculator, like, let me, can anyone, just a second, calculator. And I'm going to convert that into percentage at the end. So it's 98.9 divided by 100, right? And it's got to be squared. So I'm going to square this. Like, it's going to be multiplied by the same thing. So I'm getting 97.81%. Like if I multiply it by 100 at the end, it's going to be 97.8%. I'm going to round this off. I'm going to call this, let's call it 98%. So this is approximately, I mean, the rounded value is 98%. So there is a 98% chance of getting this particular particle, the one that has both carbons as 12. What about this other one? इसको थोड़ा सा नीचे कर लें, just a second. What about getting the M+1 peak? What's the probability of that? Just a second. So what's the probability of getting this thing over here? 61. Now in 61, you've got an OR option now. Like if you know probabilities, it's either the first one is carbon 13 and the second one is carbon 12, or the first carbon is 12 and the second one is 13. So you've got two options. You've got two scenarios. Okay, pehla wala 12 hai and the second one is 13, or the first one is 13 and the second one is 12. So that means it's an OR statement. You're getting either it's carbon 12 and carbon 13, or I mean the first one is carbon 12 and the second one is 13, or the other way around. It's the first one is carbon 13 and the second one is carbon 12. Okay, so they're two separate events. In both cases, you're going to get a mass of 61. तो इसको probabilities में translate कर लो. What you're going to get is carbon 12 की probability क्या? It's 98.1 over 100 into इसकी क्या थी? It's 98.9 actually. And इसकी carbon 13 की probability was 1.1 over 100. So that's, and when you have an OR, that means it's a plus statement. So the other one is, the first one is carbon 13, which has a 1.1% probability divided by 100 into 98.9 over 100. So it's, I mean, basically both statements are almost the same statement. They're just the other way around. So it's 98.9 over 100 into 1.1 over 100. So I'll just do the math quickly. 9 divided by 100 and multiplied that by 1.1 divided by 100. And I'm getting this. And you add the other statement into it as well. So I'll just multiply that by 2. And I get approximately, if I take this into percentage, it's going to be 2%. So the rounded value is 2%. So, and what about 62 now? 62 you need both of them as carbon 13. So it's carbon 13 and carbon 13. The first one is carbon 13 and the second one is also carbon 13. So that means carbon 13 had a probability of 1.1 over 100. The other one also has a probability of 1.1 over 100. Like if you do this, it's going to come out to be a very, very small value. It's going to be approximately close to 0. So if I do that, it's going to be 1.1 divided by 100. And I'll square that. And even if I multiply it by 100 to find the percentage, it's still going to come out to be 0.01%. So that's approximately close to 0. So I'll just round it off to 0. Like this is going to be very hard to detect. I mean, detecting one carbon 13 was hard, very difficult. Detecting two carbon 13s in the same molecule, that's even harder. So that's approximately 0%. So first thing is, we're not interested in the M+2 peak, because the M+2 peak is always going to be something very close to 0%. And it would be very hard for your detector to actually detect that, because you wouldn't be getting a lot of particles at the M+2 peak. So mostly you'll be detecting M, which is 98%, and you'll be detecting some M+1 as well, which is going to be 2%. So या तो mass उसकी 61 आ रही होगी या 60 आ रही होगी. Most of the time the particles would weigh 60, 98%. So out of 100, 2 of them would weigh 61, 98 of them would weigh 60. Or kabhi kabar na, very rarely, ठीक है, once in a blue moon you might get something that weighs 62. ठीक है? Are the probabilities clear? This one.
Yes, sir.
ठीक है, is this clear? हाँ जी.
सर अगर सेम होंगे तो मल्टीप्लाई होगा, अगर लाइक डिफरेंट होंगे तो उसको आपस में ऐड करना होगा.
नहीं, इसमें probabilities पढ़ी है मैथ में? अगर तो नींद
हाँ
पड़ी।
हाँ सर पता है, एंड में मल्टीप्लाई और में मतलब एडिशन
हाँ
होगा, तो इसमें
तो
आपने
ये
आपने
देख,
ऐड किया।
हाँ वो ऐड इसलिए कि अगर तो दोनों 12 है ना, तो होगा कि कार्बन इज 12 एंड द सेकंड वन इज आल्सो 12, ठीक है, तो वो तो एंड हो गया ना। लेकिन अगर मैंने 61 बनाना है, 61 कब होगा कि उनमें से एक 13 होना चाहिए ना, कि पहला वाला 12 है और दूसरा वाला 13 है, राइट, तब जाके इसकी मैथ 61 बनती है ना। रिजवान ये क्लियर है? तो इसमें
तो
यस
इंटू
सर।
2 भी कर सकते हैं ना
कौन सा?
सर, इसी को इंटू 2 कर दें
हाँ
तो
इसी
वही
को,
बात है।
वो वही बात है ना, वो इंटू टू, मतलब वो क्योंकि दोनों स्टेटमेंट्स तो एक ही है ना। तो उसमें दो इवेंट्स आ जाते हैं ना कि या तो पहला 12 हो और दूसरा 13 हो, या फिर दूसरा एक और फिर आ जाता है, और द फर्स्ट वन इज 13 एंड द सेकंड वन इज 12, तो उसमें इसलिए और आ जाता है, ठीक है। अच्छा रिमेंबर प्रोबेबिलिटीज के कैलकुलेट प्रोबेबिलिटीज, ये मैं इसलिए समझा रहा हूँ क्योंकि एक दफा ना क्वेश्चन मोस्टली सिलेबस में कहीं नहीं लिखा हुआ कि यू नीड टू नो प्रोबेबिलिटीज टू डू दिस, ठीक है, बट देयर हैज बीन वन क्वेश्चन वेयर दे एक्चुअली gave you a question similar where you, जहां पे ना प्रोबेबिलिटी का नॉलेज जो है ना वो एक्चुअली काम उसकी जरूरत थी, तो विच इज व्हाई आई एम गोइंग थ्रू दिस, ठीक है। एंड में ना एक फॉर्मूला होगा वो करना होगा, ये सब करने की जरूरत नहीं है। द ओनली रीजन आई एम गोइंग थ्रू दिस इज के वो जो एक क्वेश्चन आया हुआ ना, उस तरह का अगर कोई आ गया ना तो थोड़ा बहुत बैकग्राउंड होना चाहिए कि भाई प्रोबेबिलिटीज क्या होंगी, ठीक है। अच्छा एनीवेज द क्वेश्चन, द पॉइंट आई एम ट्राइंग टू मेक इज, लास्ट क्लास में ना वी डिड CH4 की मास स्पेक्ट्रोस्कोपी। अब CH4 की मास जो है ना, उसकी जो मॉलिक्यूलर आयन पीक है, इट ओनली हैज वन कार्बन आटम, राइट। तो so I'm going to compare CH4 with this molecule over here which has two carbon atoms। तो हम देखेंगे दोनों में फर्क क्या पड़ता है। तो उसके अंदर भी M और M+1 पीक है, कि M पीक किया है कि 16 आ जाए, कि कार्बन 12 है और 4 हाइड्रोजन है, तो मिलाओ तो 16 बनता है। M+1 कब बनेगी इसकी मास, व्हेन द कार्बन अगर 13 आ जाए, ठीक है, अगर कार्बन 13 आ जाए तो 13+4 कितना होगा, दैट विल गिव यू 17, राइट। तो so you're getting 16 and you're getting 17, तो आपके पास दो पीक्स हैं। 16 आने का चांस क्या है, 99%, मतलब क्योंकि 12 आने की प्रोबेबिलिटी क्या है, मतलब अप्रोक्सीमेटली 99% है, और 13 आने की प्रोबेबिलिटी क्या है, 1%, तो चांसेस क्या है, एम की हाइट क्या होगी, 99%, और 17 की हाइट क्या होगी, 1%, राइट। तो रेशो क्या बन रहा है, जब मास स्पेक्ट्रोस्कोपी का ग्राफ बनेगा, द रेशो वुड बी m m+1 रेशो वुड बी 99:1, राइट। नाउ नोट दैट डाउन कि अगर एक कार्बन होगा ना, तो m और m+1 का जो रेशो बनेगा ना हाइट का, जो आपके डिटेक्टर में जो ग्राफ बन रहा होगा, उसका जो रेशो होगा दैट वुड बी 99:1, राइट। अगर उस मॉलिक्यूल में दो कार्बन एटम्स हैं, अब जरा गौर से देखो, रेशो चेंज नहीं हो गया। इफ यू हैड टू कार्बन एटम्स, m की हाइट क्या हो गई है, 99% की बजाय इट्स नाउ 98%, राइट, यानी उसकी हाइट कम हो गई है। और m+1 की हाइट को क्या हो गया, वो 1% की बजाय 2% हो गया। तो जैसे जैसे नंबर ऑफ कार्बन एटम्स आपके ज्यादा होते जाएंगे ना, तो m की हाइट कम होती जाएगी, एंड द m+1 हाइट वुड कंटिन्यू टू इंक्रीज। तो m और m+1 का जो रेशियो है ना, उससे यू विल बी एबल टू फिगर आउट के हाउ मेनी कार्बन एटम्स डज दिस मॉलिक्यूल हैव। ये आइडिया क्लियर है?
सर
हाँ जी।
सर जितने ट्रेस एलिमेंट ज्यादा होंगे उतनी अबंडेंस कम होगी।
ये ट्रेस एलिमेंट कहाँ से आ गए?
नहीं, जो मतलब हमारे पास जो कार्बन 13 है हमारे पास, ये जितना ज्यादा होगा हमारे पास उतनी अबंडेंस कम होगी, राइट।
हाँ क्योंकि वो ऑब्वियसली ना कार्बन, खुद ही सोच रहा ना, कार्बन 13 दोनों आने की चांसेस तो बहुत ही कम होंगे ना, ठीक है। मतलब कार्बन कार्बन 13 वैसे ही नहीं मिलता, वो 100 में से एक कार्बन है ना जो कार्बन 13 है, तो दो कार्बन 13 मिलना तो और भी मुश्किल है ना। तो वो तो भाई बात ठीक है, ठीक है। अच्छा लेकिन ये आइडिया क्लियर है कि हमारे पास एक कार्बन था मॉलिक्यूल में, तो रेशो क्या था, 99:1 आ रहा था। अब हमारे पास मॉलिक्यूल में ना वी हैव अनदर मॉलिक्यूल जिसके अंदर दे आर टू कार्बन एटम्स, राइट। तो अब रेशो क्या आ रहा है, 98:2 आ रहा है। तो m की हाइट इज डिक्रीजिंग और m+1 की हाइट जो है दैट इज इंक्रीजिंग। m+2 को हम वैसे ही कंसिडर ही नहीं कर रहे क्योंकि वो मिलेगा ही नहीं आपको, मतलब वो इतना रेयर होगा कि इधर डिटेक्टर बैठा रहेगा उसको कुछ, इट वोंट गेट एनीथिंग, ठीक है, तो उसको हम इग्नोर ही कर रहे हैं। अच्छा लेकिन ये क्लियर है, इज दिस क्लियर, दिस वन? Alicia, Afreen, Amna.
Yes,
Go.
sir.
Yes, sir.
Yes, sir.
Acha, so just what if the molecule has 3 carbon atoms? Now, without doing probabilities, just follow the trend. Abhi 98% pair with 2 carbon atoms. With 3 carbon atoms, what is the probability of getting the M? It's going to be 90. कितना होगा?
सर आप रिपीट कर दें.
मतलब question ये है कि you had 1 carbon atom, right, in the molecule. So the ratio क्या था? M plus 1 ratio. That was 99:1, right? When you had 2 carbon atoms, so what was the ratio of the 2 abundances? It came out to be 98:2, right? तो अगर आपके पास 3 carbon atoms हो molecule में, तो तब क्या ratio होना चाहिए इनका?
सर 97:3.
ठीक है, 97 रेशो मतलब ये ज्यादा हो जाएगा और ये कम हो जाएगा, वो चेक भी कर लेते हैं. लेट्स डू द सेम थिंग, बट नाउ इफ आई हैव अ 3 कार्बन एटम मॉलिक्यूल, ठीक है, सो आई एम गोइंग टू डू द सेम थिंग जस्ट टू चेक. तो रिमेंबर, जैसे जैसे कार्बन एटम्स बढ़ते जाएंगे ना, तो m ढूंढने की या मिलने की प्रोबेबिलिटी कम होती जाएगी. ठीक है, सो लेट्स 3 कार्बन एटम कोई भी मॉलिक्यूल उठा लेते हैं. 3 कार्बन एटम कोई लेट्स मेक इट इसको उठा लेते हैं. ठीक है, whatever the molecule is, ठीक है. And remember, I'm not interested in the fragments at the moment. इसको हमने पास किया उसमें से through a magnetic field, and it's going to get deflected, right? So you're going to get all sorts of deflection. The heavy ones would be the molecular end peaks. So you're going to get all sorts of deflections, and अब आ जाओ, पहले तो बताओ इसकी if all of them are carbon 12, so it's going to be 36 plus 16. कितना होता है? That's what is the mass of this? अगर all of them are carbon 12, it's going to be क्या होगा? 36 plus 16, that's 52 plus 58. Can you even do the math and tell me if that's right? Is that correct, Sidra? Is this correct? 58. ये clear है कि नहीं है? Maad, अच्छा एक second just.
Sir, how is this 58?
Like I'm assuming that all of them are carbon 12, right? So what's the total mass of this? It's 12 plus 12 plus 12, that's 36. Plus 16, that would give you 52. Plus 3 hydrogens, that's 6. So that's 58. Is that clear?
Yes, sir.
Okay, so now what if out of the 3 carbon atoms, any one of them is carbon 13? So pick a mass hogi, that would be
59.
59. And that's going to be your M plus 1 peak. That's going to be 59. Then maybe 2 of them are carbon 13. So that would give you M plus 2 peak. And that's going to be 60. Or maybe all 3 are carbon 13. जिसके chances बहुत ही कम होंगे, ठीक है. So that will give you your M plus 3 peak, and that's going to be 61. So anyways, you'll be detecting, in theory, you'll be detecting 4 different particles, which are this, and they all have different masses. जो heavy वाला होगा ना, the heaviest one would be deflected less. The lighter one would be deflected more, because it's light, so it's going to undergo more deflection. अब probabilities पे आ जाते हैं. Let's try and figure out. Remember, क्या आना चाहिए? 3 carbon atoms के साथ detecting the M peak, that should be 97% now. So to get 58, all 3 must be carbon 12. So it should be carbon 12 and carbon 12, and the last one should also be carbon 12. So all 3 of them must be carbon. All 3 of the atoms in this molecule, they must be carbon 12. So it's what's the probability? It's 98.9% into 98.9% into 98.9%. So that's basically a cube of that. Okay, so that's the probability, and we'll just calculate that, और ये 97 ही बनेगा. ठीक है, so it's 98.9 divided by 100, right? और इसको multiplied by 0.989. Sorry, गलत हो गया. 0.989, and then you multiply it by 0.98. 0.989 again. So I'm getting 96.7%. If I round that off, that's approximately 97%. So this comes out to be approximately or close to 97%. So the chances of detecting the M peak has now decreased. यानी आपका जो detector होगा, that's going to be detecting a smaller amount of this. और जो M+1 peak है, उसकी height बढ़ जाएगी. So if you want to get M+1, then that means any one of them must be 13. So there are three different scenarios. The three different scenarios are, क्या scenarios हैं? It's either the first one is 13 and the second one is 12 and the last one is also 12. Okay, that's one scenario. Or you could have the middle one could be 13. Okay, the first one is 12 and the second one is 13 and the last one is 12. Or there's a third scenario, okay, which aakhri wala, that's 13. So the first one is 12 and the second one is 12 as well, and the last one is 13. So anyways, in सारों की probabilities निकालो, so it's going to be 98.9 into 100 into 98.9 into 100 into 1.1. अच्छा वो पहला वाला 1.1 था, sorry. The first one is 1.1 over 100 and this is 98. और इसी को अगर 3 दफा करो तो I'll just multiply it by 3, right? क्योंकि और का मतलब addition है, so it's you do it 3 times the same thing. So this would come out to be approximately 3%. So it's let's do that. So 0.989 star 0.989 and star 0 वो आखिरी क्या था 1.1 divided by 100. So we get this and yep, this, and then you multiply it by 3 because you have to do this 3 times. There are 3 different scenarios. And you're getting, and if you multiply it by 100, it's going to be 3.22%. So it's approximately 3%. So our hunch is correct. Okay, the hunch is that whenever you do mass spectroscopy, if the molecule has one carbon atom, that means, okay, if it's got one carbon atom, that means the ratio of the M+1 heights, मतलब वो जो molecular line की 2 different masses आ रही होंगी, and the ratio would be 99 ratio, approximately 99:1. कि अगर आप 100 particles detect करते हो ना तो 99 ये होंगे, 1 ये होंगे. ठीक है, अगर आप 200, let's say you detect 200 particles, 198 would be this one and there would be 2 of these. The ratio would be 99:1. Similarly, इसका कर लो कि अगर आप के पास 2 carbon atoms हैं तो M+1 की जो height का ratio है, that would be 98:2. If you have 3 carbon atoms, तो M की probability और कम हो जाएगी और M+1 डिटेक्ट करने के चांसेस और ज्यादा हो जाएंगे. ठीक है, इनके चांसेस वैसे ही बहुत कम है, मतलब दोनों 13 आने के या तीनों 13 आने के प्रोबेबिलिटी तो बहुत ही, दैट इज क्लोज टू 0. मतलब आपका डिटेक्टर जो है ना, इट्स हार्डली गोइंग टू डिटेक्ट दिस. वंस इन अ ब्लू मून उसने डिटेक्ट कर लिया, इनकी 0% आप कह लो. ठीक है, सो दैट्स द आइडिया कि द रेशियो स्टार्ट्स टू डिक्रीज. तो मतलब आपका जो ग्राफ होगा ना M+1 height का, that would look something like this. It's if I, and remember this is about, so this over here is your percentage abundance या जो भी आपका detector detect कर रहा है. ठीक है, and this is going to be your M peak and this is going to be your M+1 peak. And remember the M+1 peak is caused or produced by your carbon atoms. So that's the height of the M peak. और फिर as the number of carbon atoms, मतलब start होगा 99:1 से, but as the number of carbon atoms increase in the molecule, this goes down and this goes up. यानी by just looking at the mass spectroscopy you get this graph, और इन दोनों का जो रेशियो देखोगे ना आप, तो आपको पहले ही पता लग जाएगा how many carbon it's got. ठीक है, as
सर
हाँ जी,
सर ये एक दफा फिर से बता देंगे कि जो ये 99 नीचे क्यों जाएगा और m+1 ऊपर क्यों जाएगा?
नहीं वो देखो ना कि एक कार्बन आटम से फिर से शुरू हो जाओ, 16 m पीक है ना, और 17 जो है दैट्स द m+1 पीक, मतलब इसकी दो masses आ सकती है ना, तो आपका डिटेक्टर या तो mass 16 डिटेक्ट करेगा या mass 17 डिटेक्ट करेगा, राइट? क्लियर है ये? तो
जी
16
सर यहाँ तक
16 आने के चांसेस क्या है? 99%, क्योंकि कार्बन 12 चाहिए उसके लिए, कार्बन 12 आने का चांस क्या है? 99% है ना, राइट?
जी सर
तो 100 में से 99 दफा 16 आएगा और एक दफा 17 आएगा, राइट? तो इनका इनका जो रेशियो ऑफ अबंडेंस होगा वो 99:1 होगा। क्लियर है?
ठीक है सर
फिर अगर आपके मॉलिक्यूल में दो कार्बन आटम्स हो जाए तो आपकी एम पीक क्या होगी कि जिसमें दोनों 12 आ रहे हो, उसकी प्रोबेबिलिटी क्या है? 12 आने की प्रोबेबिलिटी क्या है? 99%। दूसरे वाले की 12 आने की प्रोबेबिलिटी क्या है? दैट्स आल्सो 12%, राइट? तो
जी सर
उन दोनों का जब प्रोडक्ट लोगे कि पहला भी 12 हो एंड द सेकंड वन इज आल्सो 12, तो प्रोबेबिलिटी कितनी बन रही है? 98%।
98
तो इसका मतलब है 100 में से ना 98 पार्टिकल्स जो होंगे ना वो अब ये 60 वाले होंगे एम पीक, तो उसकी प्रोबेबिलिटी कम हो गई ना, पहले क्या थी? 99% थी, अब कितनी है? 98%, राइट?
अच्छा जैसे नंबर ऑफ कार्बन बढ़ा है वैसी कम होती जा रही है।
हाँ, उसी तरह फिर अगर 3 कार्बन आ जाए तो तीनों कार्बन 12 होने की प्रोबेबिलिटी अब क्या है कि मॉलिक्यूल में तीनों के तीनों कार्बन 12 हो, तो वो 98.9% यानी 99%, 99%, 99% तीनों को मल्टीप्लाई करो तो उनकी प्रोबेबिलिटी क्या होगी? अब 97% होगी, है ना? तो आपकी जो,
ठीक है सर
और वो जो m+1 है वो वाइस वर्सा बढ़ती जा रही है, उसकी हाइट इंक्रीज होती जा रही है, ठीक है?
क्योंकि सर वो कार्बन 13 की क्वांटिटी इंक्रीज हो रही है इसीलिए वो परसेंटेज हमारा कम होता जा रहा है।
अ,
मतलब कार्बन ज्यादा होते जा रहे हैं ना तो मतलब 13 भी तो इसका फायदा
हाँ
होगा।
लेकिन वो उसी तरह ना कि जब आपके वो इवेंट्स बढ़ते जाएंगे ना तो प्रोबेबिलिटी वैसी कम होती जाती है कि लेट्स से एक दफा डाइस के ऊपर 6 लेके आना है ना, तो उसकी प्रोबेबिलिटी क्या है? 1/6 है ना।
जी सर
लेकिन अब दो दफा अगर लेके आना है तो अब चांस तो और भी कम हो गया ना, तो 1/6 इंटू 1/6 हो गया ना।
जी जी ठीक है सर क्लियर।
तीन तीन दफा लेके आना है तो वो तो और भी प्रोबेबिलिटी कम होगी, तो वो इसमें भी यही हो रहा है कि अ, एक दफा 12 चाहिए तो उसकी
कार्बन
प्रोबेबिलिटी,
12 की कम
हाँ
होगी।
एक दफा अगर
जी सर ठीक
मॉलिक्यूल
है
में एक ही कार्बन 12 उसकी प्रोबेबिलिटी 99% है, लेकिन अगर मॉलिक्यूल में दो कार्बन है दोनों 12 है तो उसकी प्रोबेबिलिटी और भी कम हो जाएगी, तो तीनों 12 लाने की प्रोबेबिलिटी कम होती जा रही है, तो इसलिए वो डिक्रीज किया जा रहा है। तो जैसे जैसे नंबर ऑफ कार्बन एटम्स इन द मॉलिक्यूल इंक्रीज, तो आपकी एम की जो डिटेक्शन होगी ना वो कम होती जाएगी, कम पार्टिकल्स डिटेक्ट होंगे एम के, और m+1 के थोड़े ज्यादा होने शुरू हो जाएंगे, ठीक है? क्लियर है?
ठीक है जी थैंक यू सर।
So by just looking at this ratio, you'll be able to figure out how many carbon a molecule has. ठीक है? So it's going to be, तो उसका एक फॉर्मूला कर लेते हैं, ठीक है? रिमेंबर द प्रोबेबिलिटी का जो नॉलेज है ना, that is not required, लेकिन in one question at least it was actually required. तो ये थोड़ा सा ना आइडिया होना चाहिए, क्योंकि अगर उसने कभी गलती से ना कोई और रैंडम एटम दे दिया। अच्छा, why are we so interested in carbon? Why what's so good about
सर
carbon?
क्योंकि ये एनवायरनमेंट में बहुत ज्यादा अबंडेंट गैस है।
हाँ, क्योंकि ऑर्गेनिक मॉलिक्यूल्स, लिविंग ऑर्गेनिजम्स, प्लांट्स, एनिमल्स, मेडिसिन,
जी सर
हाइड्रोकार्बन्स, दे ऑल, मतलब हमारे द मोस्ट यूजफुल मॉलिक्यूल्स आर कार्बन मॉलिक्यूल्स, ठीक है? सो वी आर मेड आउट ऑफ कार्बन, सो दैट्स व्हाई ये जो कार्बन की जो एनालिसिस है ना, दैट्स कि हाउ मेनी कार्बन अ मॉलिक्यूल हैज, मतलब किसी ने कोरोना वायरस पहली दफा देखा होगा, यू वुड हैव डन मास स्पेक्ट्रोस्कोपी, और उससे ना उसने फिगर आउट किया होगा कि इसकी m+1 हाइट का रेशियो क्या है, ठीक है? Do you get my point? उसने the first thing is he'll put it in this chamber, ionize it and detect, तो उसमें जो वेरिएशन आ रही होगी ना m+1 में because of the isotopes of carbon, उससे he would have figured out कि how many carbons it's got. तो अब इसका ये कि क्योंकि रिमेंबर डिराइविंग द स्ट्रक्चर ऑफ अ मॉलिक्यूल इज वेरी डिफिकल्ट, ये जो हम पिक्चर्स बना रहे होते हैं ना मॉलिक्यूल्स की, it's actually very hard to actually figure out कि what the molecule looks like. मतलब आपके पास कोई भी सब्सटेंस पड़ा हुआ है, it's very hard to, because microscopes can't actually see an atom. They can't actually, you can't zoom in and take a picture of that, ठीक है? तो इस तरह की टेक्निक से you would have to figure this out. Anyway, so this is the first formula that we're going to do, the number of carbon atoms, which is, you can figure out the number of carbon atoms by this simple formula, which is 100 over 1.1 into m plus 1 height over the m height. Okay, you can, that's the formula which you have to remember. Okay, it's m plus 1 height over m height. Like if you know, okay, let me just do a question. Remember, the ratio would not be this straightforward. It's not going to be 90. I mean, remember 198 ratio 2 is the same ratio, right? 999 ratio 10 is the same ratio. So remember, the ratio is not always going to be given in this number. It's a 2 ratio 4 can be written as 16 ratio 32 as well, right? It's the same ratio. So remember, we're focusing on this ratio, okay, m plus 1 and m ratio. So I'll just to end this class, I'll just do one m plus 1 ka ek second.
ये तो सिंपल उससे भी हो सकता है, मतलब परसेंटेज से
नहीं, लेकिन
मतलब
परसेंटेज दी भी नहीं होगी ना,
एवरेज वाला।
नहीं, वो मैं बताता हूँ, परसेंटेज दी भी नहीं होगी ना उसने। तो अगर तो उसने लिख दिया ना 97 रेशो 3, फिर तो आसान है, लेकिन वो 97 रेशो 3 नहीं लिखेगा ना, वो इस तरह की बात लिखेगा 22 रेशो 1.8। ठीक है, तो हाँ जी
सर, क्लास के बाद ये लेक्चर रिकॉर्ड, मतलब जो रिकॉर्डेड लेक्चर है अपलोड कर सकते हैं आप बाद में?
हाँ वो कर सकते हैं। एक से अच्छा, ऊपर से मसला ये कि ये पहले ना A2 में था, मुझे A2 के पेपर खोलने पड़ेंगे। इधर कर लेते हैं, जस्ट वेरी क्विकली, जस्ट वन, विल डू जस्ट वन क्वेश्चन जस्ट टू शो यू कि रेशो उन्होंने ना 97 रेशो 3 करके नहीं दिया होगा, सो विच इज व्हाई यू हैव टू यूज दिस फॉर्मूला। एक सेकंड खुल जाए, जिसमें सिर्फ पहला पार्ट, ठीक है, ये उसने दिया हुआ है, ठीक है। सो रिमेंबर, वो अगर तो रेशियोज थे फिर तो आप डायरेक्टली पता लगा लेते, तो आई एम जस्ट फोकसिंग ऑन दिस थिंग। m plus 1 रेशियो उसने दिया हुआ है 20.4 रेशियो 0.9, ठीक है। तो अब वो 100% में से नहीं दिया, वो बस रेशियो, रैंडम रेशियो दिया हुआ है। सो यूल, इफ यू वांट टू फिगर आउट, उससे कहा हुआ है नंबर ऑफ कार्बन एटम्स निकालो, सो द नंबर ऑफ कार्बन एटम्स वुड बी 100 over 1.1, the formula I wrote down, ठीक है, over m plus 1, m plus 1 is 0.9 divided by 20.4। तो इसको जरा कैलकुलेटर पे करो, क्या आता है, what do you get 100? हाँ
सर, ये बाकी एलिमेंट्स के लिए भी आ सकता है इस तरह से
फॉर्मूला? वो आएगा, अभी हम बाकी एलिमेंट्स भी पढ़ेंगे, लेकिन उसमें मैंने पहले बताया, मोस्ट एलिमेंट्स उनके जो आइसोटोप्स होते हैं दे आर वेरी रेयर। ऑक्सीजन का मैंने क्यों बताया था, ऑक्सीजन के लिए नहीं आएगा, क्योंकि ऑक्सीजन के जो आइसोटोप्स हैं वो मतलब दे आर अनडिटेक्टेबल। तो मतलब आपका जो मास स्पेक्ट्रोस्कोप है ना, दैट विल प्रॉब्ली नेवर डिटेक्ट देम, क्योंकि वो इतने कम होते हैं। रिजवान, क्लियर है बात?
यस सर।
अच्छा, so we're getting 4.01 for this. So this is approximately 4. That means a round off करना, that means you're getting 4 carbon atoms, ठीक है। So just remember कि जिस मैंने percentages निकाली थी, the ratio is not going to be given in those numbers. वो किसी तरह भी रेशियो दे सकता है। तो मोस्ट क्वेश्चन
74 जो लिखा हुआ है क्वेश्चन में,
वो तो उसने उसकी एमपी की ना वैल्यू दे दी है, उसने कहा है कि उसकी जो
इस तरीके से भी तो हो सकता है, अगर एक ही पीक पता है तो।
नहीं, लेकिन 74 है ना, हमें क्या पता 74 में क्या है।
अच्छा ठीक है।
मतलब हो सकता है उसमें ऑक्सीजन हो सकता है उसमें क्लोरीन हो,
जी।
तो उसके अंदर मतलब वो कर सकते हैं। रिमेंबर कि ये जो क्वेश्चंस है ना, दे लाइक सॉल्विंग अ पजल, तो यू हैव टू बी ओपन टू, जैसे पजल में आप पीसेस एक दूसरे के कनेक्ट कर रहे होते हो ना, फिर ट्रायल एंड एरर कर रहे होते हो। तो
जी सर, ऐसे कुछ क्वेश्चन में इसी की मतलब उन लोगों ने नंबर्स दिए हुए हैं, जैसे कि दोनों के आइसोटोप्स के नंबर दिए और बोला है कि इनकी फाइंड करो।
हाँ, तो
वो इजी है।
हाँ, लेकिन अब वो है कि ये A2 का बेसिकली उन्होंने अब AS में डाल दिया है, तो अब क्वेश्चन जो है ना थोड़े से ज्यादा मुश्किल है। जो अभी जो AS की अगर वर्कशीट भी देखोगे ना, पहले जो होता था वो तो बहुत बेसिक होता था, अब थोड़ा सा उन्होंने एडवांस कर दिया, ठीक है। ये वाला जो फॉर्मूला ना, ये आपको AS के पेपर्स में नहीं मिलेगा, तो मेक श्योर यू आर अवेयर ऑफ दिस कि अगर पास पेपर प्रैक्टिस कर रहे होगे ना, तो ये अभी उन्होंने कोर्स में ऐड किया है, ठीक है। तो इसका ना आपको पास पेपर्स के अंदर, प्रैक्टिस के अंदर नहीं मिलेगा। तो मेक श्योर यू रिमेंबर दिस, क्योंकि जब आप प्रैक्टिस ही नहीं करोगे आपको लगेगा कि जितना ये है ही नहीं पार्ट उसका, लेकिन they've just added it. ठीक है, तो इसके हम A2 में से क्वेश्चंस करेंगे जैसा ये दिया हुआ था। ठीक है, चलो ठीक है, लेट्स कंटिन्यू नेक्स्ट टाइम। आई शेयर द लेक्चर एज वेल। ठीक है,
Sir,
यस
can you please share the timetable?
ठीक है, टाइम टेबल इज मंडे ट्यूसडे थर्सडे एंड फ्राइडे। ठीक है, एंड इट्स एट 9।
Okay.
ठीक है,
सर
हाँ
सर वो बाद में आप व्हाट्सएप कर सकते हैं जो आपकी मतलब स्केड्यूल होगा सिलेबस का।
नहीं वो मैं अभी बना के ना, मैं सारा स्केड्यूल जो है ना, वो ये जो जनवरी टू मई जो है ना, वो मैं फिर व्हाट्सएप और शेयर कर रहा हूँ। ठीक है, उसमें फिर एक हम वीकेंड पे ना पास में फिर क्लास भी रखेंगे। ठीक है,
ओके सर।
चलो ठीक है, ओके, हाफिज।
Allah Hafiz, sir.